Hey
Hello.
everyone, welcome for another episode of Open Cluster Management. Um, we have a lot to discuss today. Today we'll be talking about resources and how to scale them across the fleet with the status updates. Without further delay, Tuchang, please take it away. Thank you.
Hi, good morning, good evening. Let me share my screen. Yeah, so this one is about some uh, increasing increasing requirement from community. So there is a lot of questions about when we deploy a resource, how can we know the status of the resources from the hub cluster? So today, no matter whether we use the application or manifest work or policy, when we deploy the resources, for example, for the manifest work, when we deploy resources, we just know whether the resources has been successfully applied on the managed cluster and whether it is available on the managed cluster. But we can now know the detailed status, for example, for the deployment, how many available replicas has been running on the managed cluster, etc. But there are some requirements for that. So at least three requirements here, three scenarios. The first one is that a user might want to know the detailed resources, the status of the detailed resources, like the status condition of the resources, or for example, available replicas of the deployment, a stateful set or daemon set. Uh, and it is there are also some use cases that when we do some integration with KCP, that KCP is going to provide a transparent multi-cluster application platform that in KCP they need to know when they deploy the deployment, this single deployment might be split into multiple clusters, but in the KCP interface, the user need to know how many replicas is running. In that case, we for this integration, we need to collect the status of each resources in each managed cluster that applied by the OCM, and then we need to have an aggregated controller to aggregate the status and sync it to the KCP layer. So another interesting scenario is about AI workload that I think has been raised by several different people that they want to run the AI workload on multiple clusters, but they need to build a dependency graph. Like, for example, there will be multiple jobs running in different clusters, but the flow will be submit a job in one cluster when the job is finished, and then submit another job in a different cluster. But today we cannot know whether the job is failing, running, or completed by OCM. So this is another scenario that require that we to get the status back to the managed cluster. So I'm not sure whether there are other possible scenarios. So if there is any other use cases, I think please help to iterate here. And so I also list some possible solutions. One of the solutions that we use in ECM today is the managed cluster view. That you can create a managed cluster view on a managed cluster namespace, and then there will be an agent that sync back the resources status to the managed cluster view. So this one is can be quite useful because you don't really need to watch any each managed cluster separately, but it also brings some scalability problem because we just store the whole resource back to the hub, and if there are many clusters and many resources deployed by us, and we want to know the status, there will be a lot of managed cluster view, which can make the SAD store on the hub cluster to be the capacity cannot be enough to host all the managed cluster views data load. So there are also possible options that we are discussing, like the cluster net and the proposal proposed by Ming, that is to build a reverse tunnel back from the managed cluster to the hub, so we can have an endpoint on the hub cluster to directly talk to the managed cluster's API server. So in this way, user might be quite, it could be quite convenient for the user to access the managed cluster's API server through this tunnel. But it also bring a problem for the operator or the controllers on the hub to query, because the controller will need something like a service account or a more persistent token to talk to each API server of the managed cluster. If there are many clusters, you will need to have many different service accounts for each managed cluster, and it is possible. You also might need to watch each cluster API server separately, so also brings some scalability issues. There are also some other ideas. For example, instead of providing a detailed status, we also can provide more summarized status, like degraded status, which means that if there is something that is working but not really working correctly, we can update the manifest work status to degraded. Some example, like if the applied resources by the manifest work has a degrade status condition, we can sync it back. Or when we found that the deployment or the stateful sets available replica is smaller than the desired replica, we can think it is degraded and return it back by the manifest work. But this one doesn't really solve all the problem, because, for example, in KCP user scenario, this one cannot work. And also, I think there's also a suggestion about instead of syncing back all the data in the status of the resources, we just sync back the status conditions of the resources to the manifest work. This is because in manifest work, we have the status condition for each manifest, and we can merge the status conditions of this applied resource back to the manifest work. But again, this one also doesn't resolve all the problem. Like if you use a KCP, we want to use the KCP to aggregate the status. This one doesn't work either. So I think that's all, pretty much all the thinking for me. And what I want to ask is there any more scenario that you guys can think of? And what do you think about any proposals here, and any other possible solutions you can think of?
Hey, Jen. Can you hear me?
Yeah.
Can you scroll up to the a bit upper in the page to there's a list of possible scenarios mentioned in this proposal.
Yes. Here.
I think overall, I think it's really useful to synchronize the status of the resources from the managed cluster back to the hub cluster. And you mentioned the case of workload. It can be a job or other workloads like deployments or replica sets. And another case I can think of is to synchronize the credentials like service account tokens or similar things to back from the managed cluster back to the hub cluster. And I think synchronizing the such credentials can be totally different from synchronizing the workloads. For example, first of all, most of the code credentials like service account tokens or MTLS certificates, they need to be properly rotated. And for example, and additionally, for example, in the service account token, we have to we can twist the we can change the token a bit by the field. There's a field named audience. So actually, I opened another proposal in the enhancement repo. I pasted it in the chatting board. So so I have a general idea about which is a new API model named MultiCluster service account or managed service accounts. The idea is basically we can apply a managed service accounts in the hub cluster. Then there will it can be an add-on, and the add-on will be helping us to distribute the service accounts to the multiple managed clusters. And yeah, I think that that's basically if you noticed synchronizing the secrets or service accounts, the basic idea is very similar to synchronizing the workloads, but the only difference is that the content of the tokens or service accounts are has to be secured. So
yeah.
There's one difference in this cap is that we hope to I'm proposing to place those the projected tokens, the synchronized tokens from the managed clusters into a highly secured namespace, which is a single namespace. I think we can put all the secrets to, and most of the users will now have the permission, will now have the privilege to access to the so-called highly secured namespace. So
yeah.
Yeah.
So do you think that we should separate them, like for the workload, the mechanism to sync should be at least a bit different from, for example, the credential and the sync, and for example, if we can separate them out, like if we have CRDs on the managed clusters, possible we want to sync them back also. This is kind of something like the system configurations, and there are workload and there are secrets. For each of them, we might consider a different mechanism for the such sync.
I think there will be benefits if we synchronize the if we treat the credentials and the workloads totally differently. But I think I'm still not figuring it out completely. But I think yeah, there will be benefits, I think.
Okay.
And as for the in the bottom of the in the bottom of your proposal, you mentioned we can synchronize the only the condition of the managed resources back to the hub cluster. And I think in addition to that, we can also synchronize the we can like detect if the managed resource has a sub resource named scale, because you mentioned the scenario where we'd like to know the existing replicas of the managed deployments. In that case, like we know every deployment has a sub-resource named scale, so the the reporting of the existing replicas can be simply done by getting the raising a gets request to the scale sub-resource and put them into the whatever a new field, probably named the scale or replicas in the managed manifest work.
Yeah, that's a good point.
Yeah, because the scale sub-resource and the both the scale sub-resource and the conditions are standardized, so it's totally okay to like synchronize them back from the managed cluster using the same logic.
Or maybe a condition to include all of the entire status that's not set by default, so we just get the conditions, so that if you know you're going to be working with one that you want all the details for.
Yeah, I think for the conditions and skill, I think that could be good. So should we limit the scope here? I mean, maybe we just consider about the things like the resources that has a skill sub-resource and the resources that has a status condition. It means that we don't want to support all the customer resources. I mean, some customer resource may not have the status conditions or skill sub-resource either. So, do you think that we should limit the scope?
But this can be detected dynamically by API discoveries. No, we can know the if whether a resource has skill or status condition sub-resources beforehand.
Yeah, I mean, so my point is, so if the resources doesn't have either if the resource does not have conditions and it does not have skill sub-resources, in this case, should we just do nothing that back? I mean, to limit the current scope.
Yeah, I think it's okay to just we can either reflect the facts that the resource doesn't have the corresponding sub-resources, or just leave the corresponding fields empty or new. I think I don't know if the users doesn't care about the skill or status condition sub-resources, they won't check out that field. So I guess it's probably okay to just leave the field empty or something like that.
Okay.
So in my previous proposal, I had a general idea of automating the installation of proxy tunnels in the hub, both in the hub cluster and the managed cluster. And I decoupled. I actually decoupled the portion of managing or projecting the secrets or the credentials from the between the managed cluster and the hub cluster from the previous cap, because so we can just leave the previous cap focusing on solving the connectivity issue between the managed cluster and the hub clusters, and leave the authentication and the for example, the by leveraging the proxy tunnels, we can do we can deliver any like application layer 5 traffics from the hub clusters to the managed cluster, like even like SSH or other trivial or other application level protocols. And the request of kubeAPI server, the request against the kubeAPI server is only one kind of them. So
Okay.
So the second cap is focusing on resolving is focusing on solving the authorization and the authentication against the kubeAPI server. And the second cap can be even like standalone if the managed cluster and the hub cluster are working in a flattened network. So sometimes we will not need the proxy tunnels because the network are flattened. But the second cap will still be working anyway.
Yeah, I think it's a good point that I think it makes sense that we basically should separate such sync between the workload and secret and maybe configurations.
Because on the former cap, on the very first cap, I noticed the comments is there's a lot of review comments, and most of them are questioning about the feasibility of the API server network proxy or the authentication or the authentication authorization between the clusters. So this will be decoupling the second part as a standalone cap will definitely simplifying the solutions.
Yeah. I think so for the Proxy Atom part, I think it looks good. We might need to discuss that again maybe later, and I think it should be good to go for me.
Sure.
But I
Actually,
don't...
for the first cap, I had a very simple version of MVP product of the proxy tunnel cap. I just pasted the link in the chatting board. Yeah. So I think it's basically working anyway. It's the repo is cluster proxy, and the in the repo there will be a add-on manager. The add-on manager will be automating the installation of the components of API server network proxies, both in the hub cluster and the managed cluster. And as for the components we are to deploy in the managed cluster, we can do that in a very simple approach by leveraging the add-on framework. It works pretty well. But currently, the showback of the add-on framework is that we cannot use the add-on framework to automate the components, the life cycle of the components in the hub cluster. So
yeah,
I wrote that. So I did all the installations in the hub clusters manually, like like literally calling the Kube API servers endpoints of the hub clusters and create the resources one by one. It's not really elegant though, but we can like refactor that if Atom framework can support the components in the hub clusters.
Yeah, that sounds good. Yeah, so okay, yeah, so for this one, I will, based on these comments, I think there are also other comments about the scalability, but I will refresh it again. I think there are several good suggestions in this meeting, and thank you. And I will refresh it, and maybe we could review it later on that. I think that's all for me, Mike.
That was a great discussion. Are there any other questions for Minkim and Kujan regarding this provide resource feedback to from the managed cluster to the hub for status updates?
I guess one question.
Yep.
I haven't really seen the. Is there any possibility that we might actually want to define a manifest work status object that would be pairwise related to a manifest work that could deal with scaling out how much status information might come back from a very large fleet?
I think so. This is possible. I think it is possible that we can do that, but I think the question is how do we ship that? From the current discussion, I think we want to limit the scope that we just consider about the resources that have the status condition and the resources that can scale. So this is some direction that we can build something like we call it manifestable status.
Mm-hmm.
But both the manifest work status and the Vue API will have the similar scalability issues you mentioned before, such as overwhelming watch events, is it?
But the managed cluster view is a bit different, is that we just dump all the resources data back to the managed cluster view. I think with manifest work status, we might be able to build it in a very limited scope. Like we just define the status conditions back, or we just say how many replicas based on the skill sub resources.
Mm-hmm.
Yeah, so that could be much lightweight, and we also can define some things in the manifest work to say, do you want to think that certain manifest status back? And if you do, yeah.
Yeah, I think I got it. It just reminds me of you know there in the old KubeFed v2 API there's an alpha feature named I can't recall the name, but it's like service status, and the alpha feature is basically in the KubeFed every single cluster resource such as services, it has a corresponding federated resource named federated service. So the alpha feature is like just as we say, it's adding a standalone status custom resource CRDs along belonging to the federated service. So the federated service status, it's almost the same thing we are discussing as the manifest work status.
Yeah.
The other possibility here, we still have work to do to replace the data store for Redis Graph as part of the search framework. And it makes me wonder whether we would have a better outcome to focus on how a manifest work object might include as part of its status condition the query that you would want to run against the search index in order to find related objects and their status. The downfall of that approach is that you're kind of breaking outside of the boundary of kubeAPI, but the data store could ultimately scale more easily than etcd. It would have more relaxed conditions around whether it was up to date. It'd always be a little bit behind the curve, right, in terms of the index being updated with the latest status information. You wouldn't have watches to watch status conditions, but it might give you higher levels of information about what's in the fleet at that time with less concern for the impact on etcd scalability.
Yeah. So I think we probably that in the manifest world we could have a kind of extensible reference that it can reference different data store. For example, in a small scale, you can use things like manifest work status or MultiCluster view, but if we really consider about the scalability, it can change to different data store. Is that what do you think, Michael?
That's well, and particularly the data store for search, right, which we need to migrate away from Redis Graph because of the license concern. But I throw it out just as a consideration. You know, I think we could likely make any of these work, and at smaller scale, right, order of less than 100 clusters, being able to get one object that had the static conditions through the kubeAPI without having to use another API to discover that information is more convenient. And maybe we set a hard limit, and then Min and others can provide feedback on whether that hard limit in terms of, we're only going to pull back status conditions for the first 100 objects or the first whatever objects, and see, is that sufficient for most users or not?
Sounds good.
I'm going to also ask Shenjing, I don't know, Mike, if you brought this up as well, but we've been playing with manifest work and using approximately 120,000 of them to at scale against a bunch of clusters, just to give some feedback on what we had there in the status for the resources we were applying. I think we were doing 4 or 5 resources at the time, and then most of them are static though. And then we're doing some roll up as well of this sort of third-party status for not so much the manifest work, but our higher level construct for the subscription, and get some, and we can put the results here at least, and sort of so you guys can see some of the numbers we were seeing when we did it. And so far it looks really good. But we don't have a large, I'm pretty sure the status payload is actually, we've shrunk that, and we use this sort of roll-up resource like it was being just mentioned, where a bunch of our resources sort of concatenate the results, and then we just send the single resource back. So for 2,000 clusters, we have 2,000 results instead of 2,000 times the number of manifest works. But this is a higher level use case. Like that our status is we're rolling a higher level piece up. But anyways, we can put the details. We have graphs of it as well, of the runs we were doing with 2,000 clusters.
I think that'd be great to bring to this forum as well. And Min, we'd love to kind of get your feedback on whether you see similar behavior in your environment or not.
Yep.
So just a quick question, Kujan. What is stopping us from reporting the flu status on the manifest work status? It's just a question of scalability because the payload might be too big. That's why we have to trim it. Is that why?
Yeah, I think that's the biggest reason. I mean, the problem is not only the data payload, it also the status on the resources could be changed frequently, and those change will be need to generate a lot of update operations on the hub, and this update operation will generate a big database log for the SAD and could exceed the log limit size and make the SAD goes to the read-only status. So I think, yeah, that these are some main reasons for this kind of.
Thank you. So
Okay,
we're running. Yep, go ahead.
No, I think that's all for me. And Mike, I think you have a surprise for us.
Oh yeah, there's not much of a surprise. I put it on the chat already. Feel free to request a free shirt like from Open Cluster Management. That's basically it. Thank you everyone for coming. Have a nice day.
Thanks all. Thanks, Mike.
For the free shirt. Take care, guys.